Did you know that every year, humans harvest tens of millions of tons of chili peppers to produce around 33 billion bottles of hot sauce, a flavor catalyst that can transform any dish? Just a few drops are enough to trigger an intense reaction in your brain, releasing endorphins and turning the sensation of heat into something strangely addictive, a feeling millions of people can't resist. The journey of every bottle of hot sauce begins in vast, sun-drenched fields where harsh heat nurtures each pepper, infusing it with intensity before it's harvested at peak ripeness and quickly transported to modern factories. Here, through the combination of human expertise and advanced technology, these small peppers undergo a complete transformation, crushed, blended, and refined into a smooth, vibrant red sauce, carrying a perfect balance of heat, acidity, and deep, irresistible flavor. Now, join Agriculture Insight on this journey, where tiny peppers quietly redefine the way the world experiences food. China is often called the world's chili factory, producing over 16 million tons each year. But when it comes to bottled hot sauce, the spotlight shifts to the United States, where heat is standardized, refined, and exported worldwide. Every year, Americans consume billions of bottles of hot sauce, fueling an industry worth over $3 billion. Through iconic foods like buffalo wings, burgers, and pizza, this bold flavor has spread to hundreds of countries across the globe. Did you know what the hottest chili in the world is? It's the Carolina Reaper, measuring over 2.2 million Scoville units. Just a tiny bite can trigger instant sweating, numb your tongue, and make your throat feel like it's on fire. Yet ironically, most popular hot sauces don't rely on extreme heat. They prioritize balance, preserving flavor over intensity. And that's where two distinct philosophies emerge. Tabasco, aged for years in wooden barrels, delivers a sharp, tangy kick, while Frank's Red Hot uses cayenne peppers to create a smoother, more consistent heat. That balance is exactly what makes Frank's the perfect companion for food, not overpowering it, but elevating it. So what about you? Do you prefer a sharp, intense kick, or a smooth heat that keeps you coming back for more? And now, let's head to California, where vast fields stretch beneath year-round sunlight, where warm temperatures and fertile soil quietly nurture cayenne peppers, the very ingredient behind the signature heat of famous sauces like Frank's. The process begins in shaded nurseries, with trays carefully filled and seeds placed into individual cells, covered with fine soil and kept consistently moist. After about 7 days, the first shoots emerge, but this is only the beginning. Farmers continue to monitor each tray, adjusting light and water and removing weaker seedlings early to ensure uniform growth. In the past, everything was done by hand. Farmers bent over row after row, digging small holes, placing each seedling carefully, covering it with soil and watering it. A full day of work could only cover a small area. It was slow, but precise. Today, many farms in California rely on specialized transplanting machines. These machines move steadily along the rows, automatically creating holes, placing seedlings, and covering them within seconds. A single machine can replace up to 50 manual workers, ensuring each plant is set at the right depth and spacing with remarkable consistency. Yet, whether by hand or by machine, the most important part remains unchanged: daily observation. The plants respond quickly to changes in soil moisture or weather. If not corrected in time, yields can drop by up to 30%. But when everything is managed well, each plant can produce nearly 2 kilograms of peppers, and the entire field gradually turns a vivid red, the clearest sign of a truly successful harvest. After about 5 months from planting, cayenne pepper plants in New Mexico begin their harvest season, typically from August to October, when entire fields turn a vivid shade of red. Harvesting is never random. Workers rely on color, skin firmness, and stem strength to determine whether each pepper meets the standard. Only those with a uniform red color, smooth skin, and no damage are selected, because even a single poor quality pepper can affect an entire batch of sauce. An interesting detail is that peppers don't ripen all at once, so each field must be harvested multiple times, spaced a few days apart. What seems like a simple task is actually far from easy. It requires both experience and a great deal of patience. Workers spend hours bent over under the sun, carefully selecting each pepper one by one, and before long the strain begins to build in their backs. In vast chili fields spanning hundreds of hectares, harvesting is no longer done by human labor alone. It is powered by massive, specialized machines. These harvesters move along the rows, using shaking and cutting mechanisms to separate ripe peppers from the plants, then carry them onto conveyor belts for on-site sorting. In just 1 hour, a single machine can pass through tens of thousands of plants and process up to 10 to 15 tons of peppers, a speed that would take an entire crew working for days to match. However, this efficiency comes at a cost. Precision. Machines cannot perfectly distinguish which peppers meet the highest quality standards, so mechanically harvested peppers must go through additional sorting systems afterward. For premium hot sauce production, the human touch still remains irreplaceable. After harvest, in many traditional production regions, chili peppers are not sent to factories right away, but are spread out under direct sunlight, beginning a slow yet decisive transformation. Billions of vibrant red peppers are laid across drying yards or large mesh racks, left to sun-dry for 3 to 7 days under temperatures that can exceed 35 degrees Celsius. But this is more than just drying. As moisture evaporates, the structure of the peppers changes. Compounds like capsaicin become more concentrated, while natural sugars are compressed, creating a deeper, richer heat with a lingering finish that fresh peppers simply cannot achieve. However, this process is also a gamble with nature. A sudden rain or a spike in humidity can ruin an entire batch. That's why, despite its unique flavor, this method is now mostly reserved for small-scale artisanal production, used by brands like Yellowbird Sauce and Queen Majesty Hot Sauce to craft sauces with truly distinctive character. In modern factories, chili peppers don't wait. Within 24 hours of harvest, they are sent straight into processing lines to preserve their freshness and natural flavor. Here, the peppers are washed in industrial systems using high-pressure water and rotating drums to completely remove dirt and debris. They then move along conveyor belts through sorting systems, where unripe, damaged, or substandard peppers are removed, ensuring that only the best quality peppers proceed to the next stages. This approach creates a completely different flavor profile compared to sun-dried chilies. Fresh peppers retain their moisture, delivering a bright, sharp heat that spreads quickly, while dried peppers, having lost up to 70 to 80% of their water content, produce a deeper, richer heat that lingers much longer. In modern factories, instead of being sun-dried, chili peppers are typically processed in industrial drying systems to ensure strict quality control. After being washed, the fresh peppers are transferred into drying chambers, where temperature and airflow are precisely regulated, usually maintained at around 50 to 70 degrees Celsius for several hours. After being cleaned, the peppers are fed into high-capacity grinding machines, typically hammer mills operating at speeds of up to 3,000 revolutions per minute. Within seconds, the cellular structure of the peppers is completely broken down, releasing capsaicin, natural red pigments, and aromatic compounds, forming a uniform slurry known as pepper mash, a thick mixture of pulp, juice, and seeds. The mash is then blended with salt at a ratio of about 3% and transferred into large fermentation tanks, where it undergoes a fermentation process lasting around 8 weeks, typically maintained at approximately 32 degrees Celsius, 90 degrees Fahrenheit. In this environment, Lactic acid bacteria, such as lactobacillus, convert the natural sugars in the peppers into lactic acid, creating a mild tang while naturally stabilizing and preserving the mixture. Throughout this process, the mash continuously releases carbon dioxide, CO2, and evolves day by day, almost like a living system in motion. What's remarkable is that the heat doesn't diminish, it simply changes in perception. Capsaicin remains intact, but as it interacts with acids and newly formed aromatic compounds, the heat becomes smoother, deeper, and more evenly distributed, rather than sharp and aggressive like fresh peppers. For sauces like Tabasco, fermentation doesn't take place in modern steel tanks, but in specially selected oak barrels that were previously used to age whiskey. After being ground and mixed with salt, the pepper mash is transferred into these large wooden barrels, sealed and topped with a layer of salt to prevent air from entering. Under these nearly airtight conditions, the mash is aged for up to 3 years, an exceptionally long period in the food industry. The barrels naturally breathe, allowing a tiny amount of oxygen to enter, just enough to sustain fermentation without spoiling the mixture. During this time, the mash doesn't just ferment, it matures, much like wine. The flavor becomes deeper, rounder, and less harsh with each passing year. As a result, Tabasco isn't just hot sauce, it's one of the few sauces that is truly aged like wine, where time itself is the most important ingredient, shaping its flavor. After the fermentation process is complete, the pepper mash is pumped into large industrial mixing tanks, each capable of holding up to 50,000 liters. Here, the mash is combined with vinegar and a carefully controlled blend of spices, following a precise, standardized formula. The mixture is then gently heated for about 3 minutes at a controlled temperature, just enough to stabilize microbial activity and activate its aroma, without actually cooking or damaging the natural flavor structure of the peppers. It is then transferred into continuous mixing tanks for around 4 weeks, where the vinegar gradually penetrates every part of the mash, breaking down its original structure and transforming it from a thick mass into a smooth, uniform liquid sauce. This stage is critical in creating the balance between heat, acidity, and aroma. If done too quickly, the sauce may separate. If left too long, the flavor can become flat and muted. Once the mixture reaches a stable state, it is passed through a multi-stage filtration system using ultra-fine meshes of around 0.5 to 1 millimeters, where all seeds and fibrous material are completely removed. This step defines the signature texture of industrial hot sauce: smooth, viscous, and perfectly uniform, with no graininess and no separation. The entire final processing stage, from mixing and heating to filtration, takes place in under 1 hour, yet it determines nearly the entire sensory experience of the product. From a raw, fermented mash, the system transforms it into a finished hot sauce, ready for bottling at speeds of up to 500 bottles per minute, a scale that would take weeks to achieve if done manually. After filtration is complete, the smooth and uniform hot sauce is pumped directly into an automated bottling line, one of the fastest and most precise stages in the entire factory. Pre-cleaned and sterilized glass bottles move continuously along conveyor belts, passing under filling nozzles calibrated to dispense exact volumes down to the milliliter. In a split second, each bottle is filled with remarkable precision, with only minimal deviation. Immediately after filling, the bottles move to an automated capping system, where plastic caps are tightened with consistent torque to ensure an airtight seal. A protective seal is then applied to preserve quality during transportation and storage. The process continues with labeling and final inspection, where each bottle is scanned to detect any issues in fill level, sealing, or appearance. Operating at speeds of up to 500 bottles per minute, this stage doesn't just complete the process, it transforms months of production into a finished product ready for the table in a matter of seconds. China, the undisputed king of the garlic world. Despite repeated allegations of using prison labor in its production chain, the country still churns out over 20 million tons of garlic every year, dominating more than 80% of the global supply and exporting to nearly every continent. And here's a fascinating fact you might not know. Garlic is an asexual plant. That means over the centuries, the quality and traits of the clove you're holding in your hand still carry the exact genetic imprint of its ancestors from generations past. But garlic isn't just biologically fascinating, it's nutritionally powerful too. It contains allicin, a powerful compound known to boost immunity, help prevent colds, and act as a natural biological shield that repels hungry insects in the fields, reducing the need for excessive pesticides. Interestingly, despite its humble nature, Americans aren't too fond of garlic cloves that look rough or imperfect. That's why Christopher Ranch cleverly tapped into this preference, focusing on producing higher quality, locally grown garlic, a strategy that helped the brand stand strong and weather the storm of cheap garlic imports from China. So, what do you think? Is overwhelming quantity or lasting quality the true measure of success in modern agriculture? And no matter where it's grown, the journey of garlic always begins in the fields, where around November, the first seed cloves are gently planted into the soil, marking the start of a slow but promising growing season. After about 7 to 8 months, when garlic fields begin to turn golden and the outer leaves start to dry, that's the familiar signal that farmers are about to reap the well-earned reward for their hard work. Harvest season has arrived. One key difference in garlic harvesting compared to other crops is that farmers deliberately stop irrigation a few weeks in advance, allowing the stems and leaves to naturally wilt in the field before bringing in the harvesting machinery. Unlike the heavy-duty machines used for harvesting potatoes, garlic is harvested using a specialized bulb harvester, a machine designed to gently dig up, lightly clean, and transport field-dried garlic bulbs in one continuous process, with minimal human handling. A thin, sharp cutting blade glides gently beneath the soil, lifting the garlic bulbs from the ground with precision. Immediately afterward, a vibrating shaft or shaker table helps shake off any remaining soil around the bulbs while also separating the dried stems and leaves. These dried plant parts, which hold no commercial value, are discharged at the back, either left to decompose naturally on the field or collected for composting. With high capacity, a machine like this can harvest between 10 to 20 tons of garlic per day, depending on soil type and bulb dryness. It's an ideal solution for large-scale garlic production areas that supply industrial processing chains, such as peeling, oil extraction, drying, or freezing. However, large-scale harvesting often leads to uneven quality, which is why, for the premium market, each bulb must be hand-harvested, because there's simply no place for misshapen or unattractive garlic cloves. After being pulled, garlic is arranged in neat rows on the field, with the bulbs facing inward and the leaves overlapping to create shade, protecting them from harsh sunlight that could damage the skin or cause neck burn. Over about 5 to 10 days, the garlic gradually dries thanks to the sun and wind. Its skin tightens, becomes lighter in color, and its natural aroma becomes noticeably stronger. Garlic can only be harvested within a short window of a few weeks, as leaving it in the ground too long causes the bulbs to split, lose dryness, and diminish in flavor, making it crucial for farmers to complete the entire process within this narrow golden window to preserve crop quality. Although this process is more labor-intensive and time-consuming, it yields garlic bulbs that meet high commercial standards, easier to store, easier to sell, and more appealing to consumers who are willing to pay up to 50% more than the base price. At the end of the harvest season, truckloads of garlic roll toward the processing plant, where these pungent bulbs begin their next chapter, transforming into flavorful, convenient products, with enough punch to keep any vampire far, far away. As they arrive at the factory, tons of garlic still carrying the warm scent of sunlit fields are greeted by forklifts unloading towering crates into the warehouse, a resting place before the bulbs begin their journey through a magical production process. After their resting time in the warehouse, each crate of garlic is gradually awakened and moved to the pre-processing area. Here, the bulbs are gently poured onto conveyor belts where everything begins to reveal their destined path. Rotating shafts then work to loosen and remove dirt and debris from the garlic bulbs, preparing them for the next steps in processing. In modern factories, sorting is carried out using a vibrating mesh system, where each garlic bulb rolls across screens with standardized mesh sizes. Only those with uniform size, dry skin, and no bruises make it through this first checkpoint. Amid the gentle hum of the conveyor line is a constant rhythm of inspection. As each garlic bulb passes through, it is carefully examined one last time before officially entering the path of processing. After clearing the initial screening, the garlic bulbs are further sorted based on their intended processing purpose, with criteria such as color, size, and skin condition. At this stage, no machine can replace the keen, experienced eyes of skilled workers who can inspect and make decisions on up to 200,000 pounds of garlic each day. The plump, dry-skinned garlic bulbs, playfully nicknamed beauty queens of the field, are sent to the whole bulb packing line, where their appearance is carefully refined down to the smallest detail. The garlic passes through a size sorting machine, a multi-tiered vibrating screen system with different mesh sizes. Smaller bulbs fall through to the lower tiers, while medium and large ones are retained on their respective levels. Each tier has its own chute, directing the garlic to corresponding packing stations, ensuring perfect uniformity in every finished bag. In large-scale factories, this system can process up to 3 to 5 tons of garlic per hour, without a single bulb being touched by human hands. Not every customer has the patience or time to peel each garlic clove individually, which is why pre-peeled garlic products were created to offer quick, convenient, and time-saving solutions for modern living. Their journey begins inside a spinning machine, resembling a giant wok, where each garlic bulb is gently, yet decisively caught in a swirling motion. This rotation causes the outer layers to peel away, revealing the cloves still tightly clustered together inside. Immediately afterward, each clove is guided into a steaming chamber, where warm steam envelops every surface, penetrating every crevice of the skin, softening the thin outer layer until it's ready to be peeled away. Next, the garlic passes over a vibrating table, where carefully calibrated air pressure gently loosens the peeling skin without damaging the pure white cloves inside. The loosened garlic skins are not wasted. Instead, they are collected and recycled as nutritious feed for livestock, contributing to sustainable farming practices. Immediately afterward, the garlic is passed through an optical sorting machine, a modern device that uses light technology to precisely inspect each clove, detecting and removing those with defects, damage, or that fail to meet standards for color and size, ensuring satisfaction even for the grumpiest consumers. Garlic that meets the stringent quality standards undergoes a thorough washing process to remove any remaining impurities, followed by careful drying to preserve its freshness and flavor, before being meticulously packaged and prepared for distribution to kitchens around the world. The innovative marketing strategy for pre-peeled garlic products has captured up to 25% of the market share compared to traditional whole garlic bulbs, even though this method may cause the garlic to lose some of its essence. The unique aroma of garlic will lead you on a different journey, slower, deeper, and ending with a fragrance that's truly unmistakable. First, once the garlic cloves have been carefully sorted to ensure uniformity, they are seasoned according to specific recipes that typically include olive oil, sea salt, black pepper, and aromatic herbs such as rosemary or thyme. These ingredients are carefully mixed to enhance the natural flavor of the garlic and add subtle layers of taste. The seasoned cloves are then evenly spread out on large trays or arranged meticulously on conveyor belts to ensure consistent roasting. Following this preparation, the trays or conveyor belts transport the cloves into the industrial roasting oven, where controlled heat and airflow work together to slowly and evenly roast the garlic to perfection. Like baking an apple pie, controlling the temperature is the most important factor. The roasting temperature and duration are carefully adjusted, typically ranging from 160 to 180 degrees Celsius for 20 to 40 minutes, to ensure the cloves cook evenly while preserving their flavor and tenderness. In that warmth and darkness, the natural sugars in the garlic gradually transform, creating a glossy honey-brown color. The sharpness nearly disappears, replaced by a mild sweetness, nuttiness, and a subtle smoky aroma, reminiscent of a mysterious savory jam. Although garlic offers many health benefits when consumed in moderation, about 1 to 2 cloves per day, excessive intake or combining it with certain medications, such as blood thinners, blood pressure drugs, or alcohol, can cause side effects like increased bleeding, excessive blood pressure reduction, or stomach irritation. Therefore, maintaining a balanced intake is advisable for good health. After coming out of the oven, the roasted garlic cloves are immediately transferred to the cooling area. There, an industrial fan system continuously blows cool air over the surface of the garlic, rapidly reducing its temperature. Timely cooling not only preserves the cloves' soft texture and necessary moisture, but also prevents microbial growth, thereby extending shelf life. Finally, each fragrant garlic clove undergoes thorough inspection to ensure quality and consistency before being carefully packaged and distributed to markets worldwide, ready to enhance kitchens everywhere. And that's the magical journey of each garlic clove, from the field to your table, bringing natural flavor and the power to ward off any vampires lurking in your kitchen. And as the herd grows, the precise data recorded by electronic chips attached to their ears or collars also helps farmers determine the optimal time for breeding, ensuring successful reproduction and sustaining the herd's productivity. After a period of careful care, the mother cows enter the reproductive stage. Pregnancy lasts about 9 months, and immediately after giving birth, the cow begins a lactation cycle that typically lasts 10 to 12 months. Depending on gender, the calf's journey will take 2 different paths. Male calves are not needed in milk production, so they are usually sold to beef farms, or in many cases slaughtered early to serve the production of premium products such as veal and Parmesan cheese. Famous as an animal full of emotions, the mother cow, when separated from her calf, often runs after it and calls out until she is exhausted and can no longer continue. Meanwhile, female calves are kept and carefully raised to continue maintaining the life cycle of the dairy herd. From the moment a cow gives birth, it officially enters a crucial stage, milking. When milking time comes, the cows are guided into an automatic milking station, where the process takes place smoothly and without stress. Before milking, the udder is carefully cleaned with a disinfectant solution to ensure milk quality. Then, the automatic milking system gently attaches to the udder, simulating the natural suckling motion of a calf. Each cow can produce around 25 to 30 liters of milk per day. On large farms, total daily output can exceed 50,000 liters, enough to fill a small swimming pool. Immediately after being collected, fresh milk is rapidly cooled to about 2 degrees Celsius to 4 degrees Celsius to maintain freshness and prevent bacterial growth. It is then pumped into specialized refrigerated tanker trucks, designed to keep the milk at the ideal temperature throughout transportation to the factory. From there, the milk begins its transformation into the sweet, creamy condensed milk we all love. But that is a story for the next part. As soon as the milk arrives at the factory, it undergoes a strict quality control process. Technicians carefully measure fat and protein levels, check freshness, and conduct tests to detect bacteria or impurities. Every batch is examined with high precision to ensure that only those meeting the highest quality standards proceed to production. If any issue is detected, the entire batch is immediately discarded to maintain the product's quality and safety. After passing all quality checks, the milk is pumped into the factory's closed processing system for pasteurization, a crucial step that eliminates harmful bacteria while preserving the milk's natural nutrients, flavor, and color. The milk is rapidly heated to about 135 degrees to 150 degrees for 2 to 5 seconds, then quickly cooled. This flash heating method effectively destroys bacteria while maintaining the fresh taste and nutritional value of the milk. Next, the milk enters the cream separation stage, where it is pumped into high-speed centrifuges spinning at 10,000 to 20,000 revolutions per minute. The powerful centrifugal force quickly separates the cream milk fat from the skim milk. This process lasts about 2 to 5 minutes, and the fat content can be adjusted according to the desired production formula. The separated cream is then used to make butter or cream, while the standardized milk continues on to the next stage of production. After cream separation, sugar is added to the milk, and the mixture is transferred into a vacuum evaporator to remove about 60% of its water content. If the evaporation happens too quickly or at too high a temperature, the milk can curdle, caramelize, and lose its original flavor. While if it is too slow, the milk will not reach the desired consistency and may be prone to bacterial contamination. That is why the entire process is carefully monitored, maintained at a temperature of 60 degrees Celsius to 80 degrees Celsius for about 30 minutes to 1 hour to yield a smooth, sweet, and nutrient-rich condensed milk. But the sweet journey of these fresh drops of milk does not end there. Part of the milk is diverted for powdered milk production, while the rest continues its path to become the sweetened condensed milk we know today. To produce milk powder, the condensed milk is fed into a spray dryer where it is exposed to temperatures of 150 degrees Celsius to 200 Celsius for 30 to 60 minutes. The high heat removes the remaining water, transforming the milk into a fine powder. After drying, the powder is cooled for about 30 minutes to stabilize its structure and prevent clumping. To create sweetened condensed milk, concentrated milk is mixed with sugar at a ratio of 40% to 50%. In some factories, instead of using fresh concentrated milk, reconstituted milk powder may be used as the main ingredient. Regardless of the source, the production process always ensures that the final product has a consistent flavor and texture. The milk and sugar mixture is transferred into massive industrial mixing tanks, where agitators continuously operate to completely dissolve the sugar and prevent crystallization during storage. After pasteurization, the condensed milk is rapidly cooled to about 15 degrees Celsius to 20 degrees Celsius, using a modern cooling system with chilled pipes and convection fans. This quick cooling process helps stabilize the texture, preventing separation or crystallization during storage. Precise temperature control at this stage is the key to achieving the perfect smooth consistency. Before reaching the final stage, condensed milk must go through a homogenizer, where it is subjected to high pressure of 150 to 250 bar, breaking down fat molecules into ultra-fine particles. This process prevents separation or clumping during storage, resulting in a final product with a uniform texture, smooth consistency, and rich, creamy flavor. After completing all processing steps, the condensed milk is transferred to a modern automatic packaging line. Specialized filling machines precisely measure and dispense the product into each can or container with exact weight. The packaging is sterilized beforehand to ensure absolute safety. Next, the cans are hermetically sealed using heat or pressure, creating an airtight barrier that prevents bacterial contamination and extends shelf life. To guarantee maximum safety, the sealed cans are then placed in a high-pressure autoclave, where they are sterilized with hot steam at elevated temperature and pressure. This step eliminates any remaining bacteria, allowing condensed milk to be stored for over a year without refrigeration. Finally, the cans are automatically labeled with full information on ingredients, nutritional value, and production date. The finished products are packed into cartons or stacked on pallets via conveyor systems, ready for distribution across the globe. Few people realize that the billion-dollar empire behind Ferrero Rocher actually began as a historic escape from a cocoa shortage. In the aftermath of World War II, when Europe's economy was severely strained, Pietro Ferrero made a bold decision, replacing much of the scarce cocoa with hazelnuts, an abundant resource in Piedmont. The result was gianduja, a dense block of hazelnut chocolate wrapped in foil and sliced like bread. From a modest family pastry shop, Ferrero grew to control up to 25% of the world's hazelnut supply, generating over $18 billion in annual revenue. Even more surprising, behind those iconic golden-wrapped chocolates lies an exceptionally secretive operating system, often regarded as one of the most discreet organizations in the food industry. Building on the massive success of Nutella and later Ferrero Rocher, the Ferrero family rose into the ranks of the world's wealthiest, with their fortune at times surpassing $100 billion, occasionally overtaking tech giants like Mark Zuckerberg and Michael Dell during downturns in Silicon Valley stocks. To sustain this massive money-making machine, Ferrero relies not only on secret recipes, but on absolute control at the very source of its raw materials. Through a network of plantations stretching from Chile to South Africa, the group has acquired major suppliers in Turkey, the world's leading hazelnut producer, to ensure a year-round supply from both hemispheres. Here, each hazelnut tree is planted at precise densities to optimize sunlight exposure, begins bearing fruit in its 5th year, and maintains stable productivity for up to 4 decades. Although often associated with the warmth of winter flavors, hazelnuts are in fact a peak of summer crop, ripening in August. This narrow harvest window demands exceptional speed, as even a single heavy rain can wipe out an entire year's yield if the nuts are not collected in time. On flat hazelnut plantations, Farmers can rely on a single sweeping machine to cover dozens of hectares, completing the entire collection process in just one pass. Built around two continuously rotating rubber brush systems, the machine glides across the ground, gathering hazelnuts into long, straight windrows. Secondary sweeping arms then consolidate the nuts and direct them into a storage hopper for collection. While this approach significantly reduces manual labor, its main limitation lies in its coarse mechanical nature. The machine can easily miss nuts trapped in uneven ground depressions or areas with inconsistent surfaces. In addition, sweeping directly over dry soil often pulls in large amounts of stones, twigs, and debris, while generating heavy dust clouds, placing considerable strain on the downstream cleaning process. Solving this challenge at its core, a new era has emerged with modern vacuum harvesting machines, operating like giant industrial vacuum systems mounted behind tractors. Instead of sweeping, operators control flexible suction hoses ranging from 25 to 50 meters in length, capable of reaching every corner within a 100-meter radius. Powered by high-pressure airflow, these systems can lift hazelnuts from a distance, enabling near-complete collection even when the nuts are buried beneath leaf litter or trapped in ground crevices, areas where conventional sweepers are virtually ineffective. More impressively, in a single pass, the machine performs 4 integrated processes: suction, shell separation, cleaning, and bagging. With the support of auger systems and dual-fan airflow, up to 98% of impurities are removed on the spot, allowing a single machine to replace the labor of up to 35 workers. The result is a stream of perfectly cleaned hazelnuts, ready to enter Ferrero's proprietary processing chain, where these raw materials begin their transformation into one of the most valuable, liquid gold ingredients in the global confectionery industry. After harvesting, the sacks of hazelnuts are transported directly into a closed-loop production system, officially triggering a highly confidential transformation process. Notably, most of the machinery here is designed and manufactured in-house by Ferrero, creating a critical technological barrier that makes it nearly impossible to replicate the brand's signature multi-layered chocolate structure. Upon arrival at the factory, streams of raw hazelnuts are discharged onto heavy-duty conveyor belts to initiate a multi-stage cleaning process. First, they pass through industrial rotary screening drums, massive stainless steel cylindrical cages equipped with progressively smaller mesh sizes. These machines operate based on the combined principles of centrifugal force and gravity. The drums rotate at a stable speed of 15 to 20 revolutions per minute, precisely calibrated to allow impurities, broken shells, and defective nuts to be expelled through the mesh openings without damaging the delicate skin of high-quality kernels. With a processing capacity of up to 5 to 8 tons per hour, this system ensures that only uniformly sized hazelnuts, meeting strict diameter standards, are allowed to proceed to the next stage of deep processing. Next, the hazelnuts enter the roasting stage, a critical turning point that unlocks their natural oils and creates the signature crunch. The entire process is carried out in small batches within hot air circulation ovens, where infrared sensors continuously monitor and maintain temperature with precise control at every degree. At this stage, even a deviation of just 15 seconds can shift the flavor from rich and nutty to bitter and burnt, enough to ruin an entire batch worth thousands of dollars. Immediately after roasting, the hazelnuts are sorted. The most perfectly round and intact nuts are reserved as whole centers, while the remaining ones are directed into grinding systems to produce the finely crushed hazelnut coating used for the outer layer. While the hazelnuts are being prepared, a parallel production line begins crafting the liquid core, the true soul of each chocolate. The creamy filling is an ultra-smooth blend of ground hazelnuts, sugar, cocoa powder, and vegetable oil. This mixture is fed into high-speed homogenizers to refine its texture, ensuring that no graininess is perceptible on the palate. It is then stored in temperature-controlled jacketed tanks, where viscosity is carefully maintained, fluid enough for automated pumping, yet thick enough to hold its shape once cooled. At the same time, in the coating section, massive blocks of pure chocolate, each weighing dozens of kilograms, are loaded into large-scale bain-marie melting systems. With a capacity of up to 2.5 tons of liquid chocolate, these units circulate hot steam around the vessel walls, gently melting the chocolate to preserve its glossy texture and prevent any risk of scorching. If chocolate is the soul, then the wafer shell is the structural frame that delivers the unmistakable crunch. The process begins with tens of tons of refined wheat flour, mixed with water and vegetable fats in 300-liter industrial mixers. The resulting batter is then precisely injected into hemispherical metal molds and sent through high-pressure gas baking systems. Within seconds, carefully controlled heat transforms the liquid batter into rigid wafer half-shells. Immediately afterward, an automated nozzle system fills each half-shell with hazelnut cream. At the next station, robotic arms place a whole hazelnut at the exact center of one half-shell. The two halves are then aligned with precision down to fractions of a millimeter and sealed together using a centering device. The result is a perfectly spherical wafer, enclosing a rich core of cream and a whole hazelnut. Interestingly, Michel Ferrero spent nearly 5 years experimenting to perfect this spherical wafer structure, thin and light, yet capable of preserving the smooth cream inside without moisture compromising its crispness. After cooling, the wafer spheres enter the enrobing system. Here, they travel along a mesh conveyor and pass through a continuous curtain of liquid chocolate, maintained at a precisely controlled temperature, ideal for keeping the chocolate perfectly fluid without melting the hazelnut cream inside. While the chocolate coating is still wet, the candies move through a vertical sprinkling system that evenly distributes roasted hazelnut fragments over the surface. To achieve the signature rough texture without distorting the spherical shape, the conveyor is equipped with a low-frequency vibration mechanism that removes excess coating. Finally, the coated chocolates are transferred into a deep cooling tunnel for approximately 10 to 15 minutes. This stage solidifies the structure and locks in the crisp texture, preparing the products for the final packaging process. After exiting the cooling tunnel, the final stage begins with the iconic gold foil wrapping. As each chocolate enters the center of the wrapping unit, rotating grippers gently hold it in place, while synchronized mechanical arms pull and conform the aluminum foil tightly around its spherical surface. Instead of a single pressing motion, the system performs a rapid sequence of twisting, folding, and tightening, allowing the foil to seal perfectly around every contour in just 0.1.2 seconds, without deforming the delicate wafer shell inside. Immediately afterward, a secondary rotating mechanism twists the excess foil at the top, forming the signature peak. The finished chocolates are then released onto a chute, with throughput speeds ranging from several hundred to over 600 pieces per minute. In reality, the iconic gold foil is not merely decorative, it acts as a barrier against oxygen and light, preserving the stability of cocoa fats and the freshness of hazelnuts, while preventing rancidity and flavor loss caused by humidity. From here, the finished Ferrero Rocher chocolates are automatically packed into transparent boxes and distributed across more than 140 countries. Today, consumption has shifted strongly toward China and the United States, where the product is positioned as a premium gift and a symbol of refinement. Despite fluctuations in global cocoa prices, Ferrero maintains stable profit margins through its strategic control of hazelnut supply, effectively reinforcing its position as a resilient financial stronghold in the global confectionery industry.